Hey there, welcome back. This is the third video of the series. So in this video we try to check out the APK and how it works exactly. We also see some of the static analysis tools, which is actually called Jadx, and yes, that's it. So before we start the video, just don't forget to follow me on Twitter and the other different like social media if you want. And yes, don't forget also to join the Discord server, I guess. Let's not waste too much time and see what we have for today. So, if you remember, like from the previous video, we have seen like the security stack of the Android and how the Android is securing itself, and we also saw actually how we do the rooting of the devices. So right now I have, for example, a rooted device in front of me. So we are just, for example, to check out if this is rooted or not, we can just simply go in and open up like ADB and press devices. We have this emulator that is right there. If we try to shell, so right now I'm inside of the phone. If we try to do who am I, so I'm shelled right now. But if I want to go into root and I check again, right now I'm root. So this device is fully rooted, so that's okay. Now, what we need to be understanding before we start up the video. So this video is going to be obviously having one of the we're going to be trying to reverse engineer one application, one Android application. So it's a simple application that came from CDF, so it's not going to be that hard, but it's a good way just to show you how to use Jadx in static analysis, especially for reverse engineering. So, yeah. But before that, I want to be talking about something really important, which is actually the way the APKs are getting built. So, the first thing that we have like the Java source code that is going to be right here, and then we're going to be having the Java compiler, which is the Java C that is going to be generating Java bytecode. We also can be using either Java or Kotlin, so you just have to be mentioning which programming language you're going to be using. And then you're going to be having the executable that can be executed by the JVM, which is the Java Virtual Machine. Then we have the Dex compiler, which is going to be giving you Dalvik bytecode, and then it should be also executed by the Dalvik virtual machine. But if we're going to be talking about native Android application, then we should be having some native languages. So C and C++ are a great example of that. So we have the C, CVP, and we have headers, so they can be translated into machine code that is the shared object. They can be just represented as a shared object. So libraries, and again, we're gonna be trying to see that later on when we try to dissect Android applications. So the thing that I want to be talking about, guys, now is actually this little Delvik virtual machine that is right here and the Delvik bytecode. Since okay, like everyone is knowing what Java bytecode is, but I guess some of you doesn't understand what Dalvik bytecode is and what is exactly the DVM. So, well, like understanding exactly how the Dalvik virtual machine works, I think is still really important, and it's right now like the Android doesn't use anymore like the Dalvik virtual machine. It's using the ART, which is the Android runtime. So basically, it's just another virtual machine, but it's using another technique. So I'm gonna be trying to explain both of them. So, but we need to first to be fully understanding what the Dalvik machine, um, what the Android is having. We need to be understanding the previous like virtual machine that he was using, which is the DVM. So the DVM works like in a way. How to explain that? Works in a way that like the Android 4.4 and those little like the previous Android versions were using the DVM. Okay, just to fully understand, just the DVM was used at a certain API level, so there are certain versions of Android that uses the DVM, and there are For example, the newer version are not using DVM anymore. So yeah, so that's the point. There's another question like, since we're trying to code in C++, like some native code can be executed directly by the machine, that would be more efficient, which is a great question. So for example, someone might just say, okay, so why are we even try to create those things like go through the job and then create a Dalvik bytecode that should be executed in the DVM? Why won't we just try to create a code that can be executed directly on the phone or on the device? So we can just create the applications just using C, C++ directly and execute the code. Well, I guess that's a good question. Okay, some of you might say that would be more efficient and optimized, and the code that will be running by C and C++ is going to be much more faster. Okay, like that's true, but like some of the things that we should be like understanding that C and C++ requires more like low level knowledge and expertise, like compared to using high level languages such as Java or Kotlin or whatever. So not everyone is able to understand, for example, C and C++ and use it like efficiently, and especially C and C++ are also like um, they give a lot of vulnerabilities, especially to systems. So if you're not that good at writing code, you might not read. You might not be able to write some clean code. So that's gonna be giving you more shitty problems, I guess. So you better be sticking to Java and Kotlin. So if you're not that good at low level like languages such as C, C++, or whatever. So just to make it general, so it's gonna be much more easier to be using those languages compared to these languages, so it makes more sense. So the development process like is more challenging and time consuming when we are gonna be like using C and C++. And the second thing that I think is that using C++ and C can result in, we know, less platform portability, since Java is known for being the language that is using to make things portable. So we just have to write one application and then we can like distribute that application into different platforms just by installing the GVM side of those platforms. So it's pretty known. So that's why Java and Kotlin can be used better than C and C++ in this case specifically. So this is not the issue. So we can just use the virtual machine as we have talked about. But the thing is like, for example, just using C and C++ requires, another thing, which is like managing like manually the memory, which can be like, giving a lot of errors and a lot of leaks, especially, and segmentation faults. Like this can also make the debugging and maintaining the code as I have tried to explain to you more difficult. And there is another like good thing is that, for example, we will try to see later on, but like reverse engineering C, C++ like code is much more harder compared to reverse engineering like Java or Kotlin code. So yeah, I guess it's much more harder compared to Java and Kotlin. So yeah. What else do we have to say about that? Also, I remember like I was playing around some virtual machines, so like reverse engineering the virtual machine code isn't that easy to, but how do we say that? But if you're like having some code that is going to be like, if the developer is implementing the logic inside of the Java code, then it's going to be easy because the bytecode can be reversible directly. But for example, if the if the developer is trying to create a code that runs inside of another virtual machine that was customized by him, that's another story. Then you should be trying to reverse engineer what's happening inside of that virtual machine, then go back to the Java code to understand exactly what's happening. So yeah, I think that's it. So we just have now to understand exactly how this DVM is doing its magic. So set like any other like virtual machine. I don't know if you have watched the virtual machine video that is I think 3 hours or something, but I suggest that you try to watch that video since it can explain to you. So it's just having a concrete example of a virtual machine that I have tried to reverse engineer. So it's a challenge from crack me, I guess, but you should just try that out too. Yeah, so today we're gonna be just trying to uh, we're gonna be trying to understand how we do this. So yeah, so today we're gonna be seeing an example of an application that is going to be from also a CDF. So where is it exactly? So I'm gonna be just leaving a link in the description to the application that we will be working on. So exit, so download. So I'm gonna be installing that application inside of my emulator just to be able to see what the application is having, and then I'm gonna be just going back to the DVM just to see a little what's happening inside of it and explain another interesting thing, which is Smali code. We're gonna be trying to see that also in this video. So I'm gonna be installing a rev.me, I guess, if I'm not wrong, .apk. Performing stream install, and it just happened, so I guess it should be right here. Where is it exactly? Is it like babyrev? No, I don't think so. Maybe I should just go to my GitHub repo and just get it. GitHub repo. Let's see what we have. Maybe that's not the one. I just forgot, so I'm gonna be just trying to see it exactly which one. So reverse engineering practice. Which one is it? .apk. So it's either yeah, it's babyrev, I guess. Okay, so we go right here, we download raw file. Maybe do I have it? Like adb install babyrev. I guess yeah, I just have it now. Yeah, this one. Yeah, okay, so we have like an input where we have to try to give like something, and he should be like checking if it's the valid flag or not. So it's just a simple application. Now, before we try to dive into this little application, the first thing that I want to do is I want to dissect how this application is exactly, check the structure of the application just to fully understand how this APK is getting built. So I'm going to be using APK tool. APK tool is a tool that is written in Java that can be used to decompile like APK applications or APK files. So the first thing that I'm going to be trying to do is to just use APK tool with D to decompile, and then just give it the application, and then he's going to be decompiling the application for me. So you can download also APK tool directly. I'm going to be just leaving links in the description to each of these tools that we're going to be trying to use, and then you just have to download them, and yes, that's it. So the first thing I'm gonna be entering inside of that folder, and then seeing what's inside of that one. So we see that we have the manifest file that we know, like now it's pretty known for you where the Android manifest is. So it's going to be containing like the package name, the API that was like compiled to, the permissions, the intent filters, a lot of things that is going to be happening inside of that file. So we gotta be inspecting that later on. So we also have Smali and Smali classes, and no, now for now I'm gonna be just ignoring that one. Res is going to be containing the resources, and original is going to be having also some other interesting stuff. So like now I'm gonna I just want to be explaining just a little thing, which is like just going back to the Dalvik virtual machine. So it has a feature called like the Dalvik virtual bytecode verifier, which is like a security feature of the Android operating system. So the verifier just checks the integrity of the bytecode before it's executed by looking at different types of errors and ensuring that the code is safe just to execute just before executing that code inside of the device. So that's just a feature that the DVM is having. So the verification process also going to be guys checking for type mismatches. So, for example, if there are invalid method calls, illegal access to memory, if any errors or violations are detected, like the verifier will reject the code and prevent it from being executed. So, this process is like literally crucial just to make sure that everything is happening in a secure way because it prevents, malicious code from being executed on the device and blocks any attempts to exploit vulnerabilities in the code. Like the DVM also verified this little guy that I'm talking about. Is actually one of the many security features that the Android employs just to protect the device and user data. But does that actually will be stopping, for example, a malware author from executing their ideas? Well, I guess the answer is no, guys. Well, this is where obfuscation-like techniques are commonly used just by the malware authors just to bypass security measures like the Dalvik bytecode verifier. Also have reflection. I think I have just explained that concept in the previous video. So reflection is really used a lot by malwares, I guess, which allows like targeting methods through strings and dynamic code loading are two such techniques that are used a lot, I guess. Just adding some things to that, like you can write code in native. That can be also a way to evade detection by because the native code can be manipulating directly what's happening inside of the application. So yeah, so now this is the point where we need to be understanding how the bytecode is created, which we can see, for example, this Smali code. So this Smali code is more like the assembly in Windows and Linux like executables. So for example, for Linux and Windows, we usually see like an object. We try to get the opstamp of any kind of executable which will be containing some assembly code that the CPU is going to be translating into machine code 0 and 1 to execute it. But Smali code is the human representation of that bytecode that the DVM, for example, is going to be executing. But in this case, like as I have like explained, the DVM is not used anymore. So there is something else used, which is the ART, which is the Android runtime. So, but we always refer to the DVM because the DVM is one of the pillars of how the art was working. So it has just a small, not a small like change, but there was a change that happened. So we just have to understand that change, and that's it. So this bytecode that we will be trying to create, guys, is going to be so splitted into methods, as we already know that in any kind of programming languages. So this Smali code, we need to be understanding this little guy here. So that little guy here will be then compiled into class. So just to you can understand exactly what I'm talking about. So when I'm talking, so I think there is the image here. No, the image doesn't. So basically, yeah, if you try to see that, so the Dalvik bytecode is the one that comes after like I mean before the Smali code. So for example, Dalvik bytecode and then Smali code, and then it's going to be executed by the DVM. So yeah, so that's it. So for example, the thing is that we should be trying to see the Smali code, but before that, we can try, for example, to see it. It doesn't matter, like we can do it. Who cares? Okay, let him just download that, and at the same time, I'm gonna be just giving you an example of how this Smali code is working exactly. So for example, we have a class that contains a method big that returns an integer, and it's just going to be multiplying the parameters just by 2. We also have a static integers, another method that is static, which is called foo, that's going to be taking like an integer and then an object iron byte is p. So there's going to be just using the method that was called inside of big, and just call it with the parameter a and just store the result in b and return a plus b, the sum of them. So for example, this is the double bytecode of this method when you try to like compile it, let's say into Dalvik bytecode. So it's going to be allocating 3 registers. So the thing is that you should be understanding is that virtual machine is trying to mimic what the computer is doing. So it's going to be having its own registers. It's going to be having maybe also its own memory space. So it's actually a way to mimic what the computer is doing by having its own instruction pointer, by having its own registers, by having its own memory space. So once you understand that, then whenever you see any kind of bytecode that is going to be executed inside of a virtual machine, then you should be expecting virtual registers to be used. The same thing is happening here. So we have like virtual registers that are going to be used. So we are allocating like 3 registers. So by using this command, and then we're going to be doing the multiplication operation of v2 by 2, and then storing the result to v0, and then we're going to be returning the result in v0. So this is the end of the method. So this is what the big is going to be having, this little function right here. So what about the other one, which is the static int foo? So it's going to be method static foo, and then you give like this parameter just to say that it's going to be taking like this little guy right here. So, and it's going to be having 4 registers, for example. But the thing is, like, before I try to explain like the static foo for you, there is a really important note like to check. Why are we having like 3 registers here? Like, we should be like asking that question, since like the big is only having 1 parameter and that parameter is just multiplied by 2, but right here like we're allocating 3 registers. So why? And where is that v1? Also we have v0, v1, v2. Where's the v1? So the answer like is that there is a register that used to pass like the argument, and the other register, which is v0, that is used to store um, and return like the result of the method. And like the third register, which is v2, is just reserved to pass the reference to the current instance. This actually, if you remember, there is this little this right here that we use a lot in Java and Kotlin and whenever. So it's going to be just pointing out to, so it's just a reference to the current instance that we are using. So since this method is not declared as static, so we need to be using a third register to be pointing to this instance. Now if we try to understand a little what this static is doing, since now for example this method is static, like we don't have an additional register, as you can see. So we just have to learn a little about its instruction, and like that's it. So the first thing that we can see is that it's invoking a call to the method pig in ironbyte. So it's invoking v3 v2. No, I'm sorry, it's invoking this little method, as you can see, pig. So he's calling like by calling the object, he's just doing lcom example ironbyte, and then calling the method pig with the parameter I, and then just returning that one. So we need to be understanding that one. So, and then moving the result v0, and then adding, v2 with v0 into v1, then returning v1. Now the thing is that we should be at least is learning a little about these operations. It's more like understanding the Smali syntax. Yeah, it's more like you're trying to reverse engineer. Let's for example say executable in Linux that is using 86 64-bit architecture, so you need to be understanding that assembly to be able to read that code. So the same thing happens when you're trying to read Dalvik bytecode. You just have to be able to read that Smali code to be able to understand what those methods is doing. So basically that's a good thing, guys, to be able to read Smali code, because at some point if you want to be patching some features inside of the application, especially if it's not using any native libraries, then you just have to be patching directly to this one. And the same way we're trying, for example, to patch an executable, we just have to go. For example, let's suppose there's a conversion that is happening, you want to patch it, so you just have to go to that instruction and then you change it from GNI to, for example, just GN, just jump if not equal or something like that. So the same way you're doing for Android applications, I guess too. You just have to go into the Smali code and just understand how this like syntax is working, and then you can change, for example, instead of returning v1, I'm gonna be just returning, let's say 2, or let's say v2 or v1. So if I try to change that code and then just recompile or rebuild, or let's say reback the Smali code back, then we can create another class that can be injected. But the thing is that there is a good question right here, is that how do we verify if the application is changed by the signature? So once you change the Smali code and then you recompile it back, the signature is going to be changed, and your application might not be able to be installed on the device that you want to try on. So that's why you should be re-signing the application back and then installing the application inside of that phone. So that's something that we will be trying to see in a separate video. This is going to be just about patching um, Android application and understanding how things are happening inside of it. So yeah, so for example, to move a constant, immediate, or resistors or whatever, you just have the destination and the source. So for example, I'm moving 0x123 into v5, so moving v5 inside of v4. So this is the way how you are like assigning like constant values to registers. You just have to be using this const. If there is anything like math related, you just have to you just have to be naming the operation that you want to use, and then the type, and then you just have, for example, v0, v3 added together into v1 and so on. To method invocation is there is like a way that is virtual and static. So each one of them is depending on which function you are wanting to be calling. For example, this one is going to be using pig that has 2 parameters. So, and this parse end is just having 1 parameter, but it's the static. So if it's static, then you don't be having to add another parameter for this instance. That is going to be just a reference to the actual instance that you will be working on. But if it's virtual, then you should be just adding another parameter to it. So getting the return value, you just move result into v5. So you just do the operation and then you just call the move result with the register that where you want the result to go to. For example, to set or get values from the fields, let's suppose you're having a class and you want to be just, setting fields inside of that specific class, or specific, for example, you create the class and then you do the instantiation of an object from that class, and you want to set, for example, just saying to explain for you, for example, there's int x there, so it's part of the class. So let's suppose it's also public for sure. Yeah, so there is a public like attribute x, so you want to be setting or getting values from that x, which is field. So you just have to be doing those little instructions. So I get, so, and I put. So yeah, that's it. So to do an instantiation of a new object, you just to be using new instance, and to do some conditional things, there's like if not equal, if equal, and then you're gonna be, so these two little guys will be just compared together. So you go to label A, and label A is going to be doing something. So it's more like you're writing something in assembly. So it's not it's not that hard to understand. Yes, so for example, now if we try to go and see the Smali code that we have right here, so I'm gonna be trying to see the main activity Smali. So this is like the main activity Smali that we have. So don't forget, guys, that this is like the application that we are going to be seeing. Let's suppose, for example, I want to go and check the invalid flag logic inside of this Smali code. So I'm gonna be just searching for invalid flag. For example, is there like any flag? Yeah, there is check flag. So check flag is this little guy right here, which is a button, as you can see. So it's actually just trying to assign some constant value to v2, then invoking a virtual which is find by view ID. So since, as we have like talked about, the resources is going to be having all the graphic things, and then Java code will be pointing back to these resources by using like the find view by ID functions and other functions that are already like prepackaged with the application, and that you can just have in your Android SDK. So yeah, like this is like what this function is having. Is there like anything interesting inside of that? Yeah, we have like main activity 1 and we have the 2. So main activity is just split into different like activities, and we also have flag checker that is supposed to be a function, I guess, that is going to be doing the check for us. So it's something that, and by the way, guys, if you are trying to patch, for example, this code, then you should be like understanding very well the syntax. Otherwise, if you try to make an error and then you just recompile the application, then maybe the application won't be running for you, because the Dalvik virtual machine verifier is going to be checking if the bytecode is cool, is good or not. So if it's bad, then it's not going to be executed by the virtual machine, which is the art. Okay, now if we try to go here, is there like any invalid like checker? Invalid? No, there's no invalid flag here too. Maybe it's this one. Yeah, this one is containing the invalid flag, which is the message. So as we can see, this little guy right here, so it's going to be checking the flag. So we just have to be having some static analysis, reverse engineering skills to be able just to go back and understand what this input is, what the input should be that will be giving the right flag. So this is basically what the Smali code is about, guys. But for now, like, I'm gonna be using something else. I want to go one level higher than that. I don't want to be reading assembly, so it's more like you're using IDA and then you just want to see the decompile like option that can give you, for example, just approximately how this code is, for example, in Java. So I'm gonna be just using another tool, which is Jadx. I've like already tried. So this one is just having revme, not the actual like APK that we're working on. So we just have to to open up another like file. No. So like I want to be like directly. Okay. Explorer. Okay. No, not this one. Okay. Yeah, babyrev. Okay. Now we're having like the babyrev in front of us, and as you can see, guys, like right now I'm having, for example, this is the APK signature, as you can see, like where you have all the informations about how the application is signed and all of that. Um, we also have like the resources file, which is going to be containing the Android manifest, which is the first thing that we should be trying to see. We also have two classes, which are these little two dex files, which are actually the actual like code of the application itself. But for example, we can't see the Smali code. So the only way, for example, not the only way, but to be seeing like the Smali code, then you should be just using APK tool to be able to see the Smali code, as you can see, which is like com, which is the package mobsack and babyrev, and as you can see, those little guys right here. So yeah, so I'm gonna be trying to show you, just to walk you through a way on how you can do the static analysis to reverse engineer like this little application that we have right here. So you can grab something to eat or something to drink, and yeah, let's just start out with the Android manifest file. So the first thing that we should be analyzing, so we see that the Android compile SDK version is 28, which means that this application requires 28 plus Android like APIs or Java APIs to be able to be run. So we uses like the minimum SDK is 21, but the Android target SDK version is 2028. So I'm sorry. So the latest one is 21, and the target one is 28. So it's running from 21 and above. So this little guys right here, I'm gonna be just ignoring. So is debuggable. So I think this is like more of vulnerability. So if you're trying to release that into um, in release mode, you shouldn't be activating the debuggable like mode. It should be false. But yeah, I think this is just a simple like application that we're trying to learn from, I guess. So we have one activity which is the main activity that has the action main, and it is one of the category of the launcher, which means that it's going to be launched once the application just loaded inside of the memory, I guess. So there is no so that's an intent filter, so just to make sure that the application handles these two little actions. Well, this action, which is the main, for example, when there is the action to the main activity, then the application should be handling that, since it has the intent filter like uh, configured rightly inside of it. So the third thing that I'm going to be doing is I'm going to be now checking the source code. So I want to be checking the main activity, and as you can see, yes, we like more having like Java code that we can read. So the decompiler mode is much more better to the eyes compared to the Smali code, I guess. Smali code is more like a way, I think, for me to be able to patch things, but if I want to read the code of the Java, I just want to be using Jadx, I guess. There are some times when the code is obfuscated, so that means that Smali is obfuscated, so even the Java is going to be obfuscated. So maybe if we had like that's for sure, but I don't know how to explain this for you. But there is also a video that is going to be about Smali and obfuscation. Hope I hope I can make it. I hope. Yeah. So yeah, so the first thing that we can check out, so I'm gonna be just ignoring all this on create and life cycle that the activity is doing. So and then just jump right away to where the logic is happening. So this is the invalid flag, this is the valid flag, so there is a result that is going to be stored in this little variable right here. So there is a method that is called check flag. If we try to get into it, we have just the logic of the check flag just in front of us. So I guess now we just have to be able to reverse this little guy right here, I guess. So what do you think, guys? How can we do this? Now I think this is a great way just to pause the video and try to do it on your own, and then just go back and do it with me if you want. So it's just a suggestion, so it's up to you, but let's just start this out. So what do we have? So the first thing that we should be checking out, so the flag is taking a string, which is containing the flag that we will be checking. So if the flag is not starting, there's a not right here, it's not starting with mobisec, then or so, then you should be returning false. So all those conditions should be satisfied. So I guess I'm gonna be just opening up we can just use this little guy right here. So I'm gonna be just using this as this way. Okay, so yeah, so uh the first condition is that like the flag should be starting with just this little string right here. Just gonna be using it, all of it is right here. So yeah, flag starts with mobisec. So the second condition is that there is this little guy, so new string builder flag dot reverse dot toString, and then char at 0 should be okay. So this little guy right here is just building another string from the flag and reversing it and checking if the value at the position 0 is this little guy right here. So that means, for example, if I give, for example, iron byte, then if we try to reverse it, so it goes becomes et by etc. So the first one is like that. So that means that the flag should be like ending with flag should be ending with this little guy right here. So which means that, which is like now the format of the flag is like that. So some stuff, and then it should be like that. So we just have to be finding the some stuff that is inside of those little two guys right there. So yeah, the third condition now, what do we have? Okay, now the third condition is that the flag length should be 35. So flag length is 35. What is the fourth condition now? The fourth condition is that the flag, when we try to lowercase it and we just get the substring from 8, it should be starting with this is. Okay, so that means that if we take the flag from the position 8, that part should be equal to this right here. So, okay. So if we try to check, like we have like 1, 2, 3, 4, 5, 6, 7, 8. So that means that after this open up, if this open semicolon, then we should be having like this is, which means that now the flag, so flag from position 8 should be equal to this is. Yeah. For the fifth condition, we have like what now? We have now what? So we have new string builder, flag reverse to string to lowercase dot substring dot starts with cdx get string r, which means the resources file, which means there is some kind of hard-coded string dot last part. So we're gonna be checking that little guy right here. So we're gonna be checking that right away later on in the resources file what that last part is. Okay. Okay, I'm gonna be just now for this for the fifth condition, I'm gonna just be we need to check the resources file. Okay, we need just to be checking the resources file at this little address right here, this little value at, yeah. For the sixth condition, like what do we have now? If we go back to the flag checker, so we have like flag at the character 17 should be underscore. Okay, so the 17th char should be equal to underscore. Okay, now like the seventh condition. So the seventh condition is that the flag at the character like int get y multiplied by math power of get x get y should be different from flag at the character math power of 2 2 2. I'm gonna be just taking all of that because it's a long one. Not this little. Okay, this is flag character. Yeah, this gonna be just come on. Okay, just be. Can we just please? Okay. I just want to be taking all of that. I guess I can't, so it's okay. Okay, this is gonna be just using that one. Yeah, I'm just taking all of that. I don't use all of that. Okay, is different from this little one right here. So if we go back a little so and see what this getY is having. GetY is returning 3, and getX is so this is like we can just change it with 2, and getY we can just change it with 3, and this is a 3, so 2 to the power of 3, so it should be different. So this position is 8 by 3, which is 24, and so all of that is 24. Yeah, and this little guy right here, so math power of 2 to the power of 2, which is 4, and if you do it like with a 2, 4 to the power of 2 gives you 16 plus 1, which just giving you like all of that should be just converted to 17. So the flag character at 24 should be different from they should be equal since we have the not, I suppose, from the beginning, if I'm not wrong. Like there is not. Flag character at that one should be different from like the math power of that one plus 1. Yeah, in this case they just have to be different. Yeah. Okay. Condition 8 now. Now the 8th condition, which is later on, just we see it. So there's the dot bam, so the bam flag uppercase is taking a lot of things. Okay, but it's equal to this little guy right here. I just want to be copying all of that. Okay, so it should be equal to, so it's having 2 parameters if I'm not wrong. Can I just check the BAM? Yeah, BAM is just having 1 parameter, which is a string. Flag.uppercase.substring from those positions, which is getY by getY, which is 3 by 3, 9 by 2, by 2. I guess I'm gonna be just, maybe we'll try to reverse engineer back this little function right now, I guess, but should be just equal to this little guy right here. So 3 by 3, 3 by 3 by 2, which is just 18, I guess. And then you just have to substring from 18 to math power get z, which is 5. This one is 5, get x, which is 2. So 25 minus 1, which is 23, I guess. 24, I'm sorry. Yeah. So we just have to substring from 18 to 24, and should be equal to that one. So I'm gonna be just setting the condition. So you can just have to take that one. Okay, dot equal. You just have to take all of that as the latest condition. And what do we have also? We have like other conditions aside from the BAM. I guess we have like flag dot lowercase character at 16 should be a. So ninth condition is like flag dot character at 16 should be equal to okay, so the 16th character should be equal to a. There we have now 10th condition. So 10th condition, flag character at 16 should be different from character 26. So if they are different, then we return false. So actually, this one is equal. Yeah, they should be equal. So the flag character at 16 should be equal. So flag. So just can take that one like right here directly. By the way, guys, we can just uh, we can just parse these conditions, feed them to Z3, and Z3 just can give us the response. So I'm just trying to do this like manually, so you can just understand exactly how these things are done manually, and then you can just feed it either to Z3 or even ChatGPT can do the job for you just when you give it all those things. But we can try to use ChatGPT then for that one. So we just have to be extracting like everything, and then we can just use ChatGPT for doing like the for building up the flag for us. So flag to uppercase like character at 25. So flag the character is just getting this little guy right here should be just equal to that one. Yeah, I guess, do we have like any other things? So yeah, that's it. So now we just have to go into like we need to be checking this little address right here. So let me just open up this one, this little guy. So we go into the resources. Um, we see like there's like, I'm sure there's like a folder, I guess, that has values. So we should be like having this little guy right here. Where is it exactly? Nah, yes, right here, I guess, maybe. Yeah, resources, values, strings. Yeah. Now if we go and check, like, yeah, we have like, this is the last part, and we have like verses. So this is like the last part we should be having. So you just have now to go back. Now it's a little okay. So now we can go back a little. We can close this one. Close this little one too. Yeah. So we need to check like the resources. So fifth one. So wait a second. What is the fifth one? One that has the logic. Yeah. So a reverse to string to lowercase dot substring from one that starts with get string to the latest part. So like the flag at the end should be starting with the reverse of this one. So we need to check. So if we reverse the flag, we should be getting yeah, so we should be just getting this little guy here if we try to reverse it. So SES no, wait a second. So it's what exactly? So I guess like, yes, SES, like you just have to be REV. So there's like sysrev. So we just have to be having that one right there. So yeah. So I think that with those conditions, like there is something that we should be like trying to figure out, which is like the BAM. And there's also like by just using like the 10th and the 11th condition, we can like determine the characters that we can like use to build up the flag now. But for example, we have like this one, so we have like this should be like in the beginning, and we have like a lot of things that should be like having right here. So I don't exactly know how much, but we also have this at the end, which is this rev. And we just have to be figuring out what those other things are just by reverse engineering the BAM. So the BAM is having something that we should be understanding. So it should be equal to equal to this little guy right here. So it's actually iterating through the string that will be passed to it, which is this one. Since if we try to reverse exactly, if we try to figure out what is the substring from 18 to 24 that should be equal to this one, then we should be trying to reverse this function to be taking this little string right here and then generating back the string that should be right here. So it's more like you're having like bam of x, it should be equal to this one. So you just have to be doing bam like bam minus 1 to the x of bam of x, and then you just have to be passing down bam minus 1 to this little like string right here. So we need to be like writing down bam minus 1 to be able to get like the x, which is this little string right here. So we just need to be writing it reversing, we just have to be just reversing back that function. So it's not that hard. So it's just extracting the character from the string. Then if it is between like a and m, then we just add c plus the ASCII code of the dash r. So if it's between a and m, it's going to be doing also that one. So if it's between n z, subtracting, and then the output, you're just adding it back together. The output is actually a string, so you're just generating a new string. So it's not that hard to be just implemented. We can just implement it, so implement that one. So yeah, so just have to be doing solver.python, and yeah, I just wrote it. So we have like the ref bam that is going to be taking the target and just going into the different things that we can create. So the target is this little string that we have. So if it's between a and m, then you do the same thing, you do the opposite thing. Otherwise you do just minus. So since we have, for example, a and m is going to be since a and m you're going to be adding, so you just have to be, so wait a second. Yeah, since if the a and m you're just adding, so you just have to be mimicking what's happening, otherwise you just have to be subtracting. Yes, so if we try to run that one, so Python 3 solver is just to be having really, so that was just pointing up to really. So I guess so there is, this is like should be like, there is also, by the way, this later there's basic, yeah, if I'm not wrong. And this little is just really, this is just really basic ref. So there is only one function that was also like returned, which is after doing all the checks, like you return the flag from a to the flag -1 that you checks what matches, and then you pass in r. So what does matches do? Matches is going to be actually doing a kind of, let's say, which is actually just doing the, that's the thing, that r is just pointing to the get r function, which is just a method that returns the string. So if you matches is going to be actually matching a regular expression. I don't know if you know what a regular expression is. Regex basically. So that means that the output should be just matching this regular expression, and as you can see, this regular expression that he has defined here is not that hard also to be just to understand it. So we're just basically going to be going from 0 to 26 and initializing upper as true, which means as a 1, and if there is a 1, then r is going to be having from a to z as uppercase, otherwise it's going to be from a to z in lowercase, and upper is just going to be alternating, so from 0 to 1, 0 to 1, which means that the character should be matching the pattern uppercase, lowercase, uppercase, lowercase, uppercase, lowercase. So you just have to be doing that. I don't know, we can just for example just quickly write something that can they can just do the same thing as he's doing. This is a regular expression one. We can either do it like find a tool online, or we can just write it, so it's not hard, like regex it's Python. So just have to be defining that as get flag, for example, that is going to be taking like the flag and just transforming that flag. So the answer is just like that. So for I in the range of the length of the flag, what you have, like if the I, for example, models to like is equal to 0, which means that it's odd, it's even, I'm sorry, we just append the flag of I dot like the upper version of it, otherwise and by the way, I also have like the 2 answer dot append flag of I dot lower and answer dot append this little guy right here. So we just have to be appending that one. After we finish, like we can just append it. What else do we have? We just have to be returning, for example, just joining back them together. So the answer, yeah. So we can just print movie-sec movie-sec, and then we just get the flag, which is like, this is really basic rev. Actually, you just don't have to be having that one. Yeah, I guess that's it. We just don't be having to be using that one. I guess like there's like basic rev in here. Yeah, that's it. If we try to run that one, this is like basic rev. There is a space that happens to be having. Why do we have a space? Anyway, like who gives a shit? Just have to be taking that one. Just take it right here. Just get this right of that. This little guy. Just go and try that out. Without flag. Why? Did I try to do something wrong? Maybe there's like something wrong. Is there like... Yeah, I always... Yeah, I just forgot this. We already like said that the 17th one should be A. I just forgot about that little one right here. Where is it? Where is it? Where is it? Yeah, the 16th character should be A. Yeah, anyway, so this is just, guys, how you can just do some reverse engineering of any kind of, let's say not any kind of applications, but if you are going to be just working on some real application or something that is working in prod. So at the end, this is just a simple CDF like application APK just to show you how you do static analysis. But if you're going to be just working with something like in real life and all of that, then you should be just understanding how those things are working. Otherwise, like, you won't be able to understand what the application is doing. So if you just go back a little, I just want to show you something like the difference between the DVM and the art. So the DVM is more slow compared to the art. So by the way, the DVM is just using just in time, and the art is going to be using the ahead of time. So what is just in time? What is ahead of time? So basically, just in time means that just in time is just a way to compile methods. So for example, when the execution of the program or the application is going, like when you do a just-in-time compilation or compiling things just in time, means that when the application requires a method, it just compiles that and then compile the method and then just use it. but the ahead of time is just is a different thing. So ahead of time is going to be compiling a lot of some methods before executing the application, just to make sure that whenever the application requires those methods, it's going to be using them directly. So this is what ahead of time is. I guess that's it. But there's also another interesting thing I just forgot to explain to you, which is the ODEX, so the optimized DEX. So ODEX Android, it's something that is just an optimized version of the application that you have. So what is ODEX Android? So like the optimized Delvic VM virtual machine code. So just separately from the .apk file and contain machine code specific to the device. We know that one, but it's an optimized version of the bytecode, the DEX bytecode. So yeah, that's it, I guess. I think I have just explained to you a lot of things in this video, so just see you and I guess in the next week. The next week maybe you're gonna be checking out some instrumentation tools, Frida specifically for people who are interested in that. Yes, so don't forget to subscribe if you are completely new to the channel, and don't forget to activate the notification bell too to get updates on new videos, and that's it. Bye.